Section 6.6, normal as approximation to binomial. At the end of your textbook, there are all these tables that they all are for continuous variables. As you see, they all are decimal for the z. They are not for the discrete. For the discrete, we just have for binomial on appendix A, which is just all the way up to n equal 8. But the rest are all tables are continuous variables. They are not designed for discrete. So in these sections, we want to try and convert a discrete problem to continuous. Conditions of normal distribution as approximation to binomial is, first of all, we have to make sure that n times p and n times q both are greater than 5. Greater than equal to 5. And then mean is n times p, and the standard deviation is radical npq. Now, first we want to discuss a discrete problem that we had in the previous sections in earlier chapters. Based on Harris poll, 60% of adults believe in devil, assuming that we randomly select 5 adults. Use table A1, which is designed for binomial for the discrete, to find the following. What is the probability of 3 out of 5 adults believe in the devil? So on the table A1, which is designed only for discrete, n is 5 and x is 3. What is 3 out of 5? And here, what's the probability of success? Is 60%. So the numbers would be 0.913, 0.346. Now, we could also use the binomial formula. Binomial formula, n is 5 and x is 3, 3 out of 5. Probability of success is 60%, and q is always 1 minus p. So if this is 60% or 0.6, the other one is 0.4. So in that case, probability of 3 out of 5 is 0.346 or 34.6, which is also use the calculator instead of the table and the formula, as we showed you before. Second VARS binomial PDF NPX. This is designed for discrete. N is 5, probability of success is 60%, and x is 3. 3 out of 5 with 60% success. So there are 3 ways to solve these discrete problems, which we normally prefer the second one, which is easier to do using the calculator. Now, the part B of this problem, what is the probability of at least 2 out of 5 believe in the devil? That means probability of 2 plus probability of 3 plus probability of 4 plus probability of 5. In that case, for part B, means if you want to find probability of, if you want to calculate probability of at least 2, is probability of x equal 2, x equal 3, x equal 4, x equal 5. So you need to calculate all this, or if you want to use your calculator so you don't have to find the probability for each numbers, in that case, you're using binomial CDF instead of PDF. Instead of PDF, you're using CDF, cumulative. So in that case, 1 minus binomial CDF. So when for that one, you put n equal 5 and x equal 1, and that would give you the same number, 0.913. So this should be Now, so that problem was a discrete because you are talking about a small number. This problem also is discrete, but look. In a Mendel's famous hybridization experiment, he expects that among 580 offspring, 145 of them would be yellow. So 580 P's and 152 are yellow, and probability is 0.25% to get that. Now, probability of X greater than 152 means you have to find probability of X equal 152, 153, 154, all the way to 580. So you see there are so many probability that you need to calculate. You need to do it 428 times. So it's not easy to do it this discrete. So for that, we try to use the z-table. If you want to use the z-table are designed for continuous, not for this problem, because this problem, they are talking about the number of p's, which has to be a discrete number. It has to be a whole number. So somehow, for a problem like this that is a very, very long calculation, we want to convert discrete number to continuous. In order to do that, we always add 0.5 or subtract 0.5. So, and the table to do that is on this page 7. These are the example. If we ask you to find X greater than equal to 8, then you need to start from 7.5. Means you need to subtract 0.5 from that. Why? Because we want 8 to be included. If we say X only greater than 8, means 8 is not included. So in that case, you are adding 0.5 to this. So it would be 0.8.5. If we say X is less than equal to 8, means 8 is also included. So in that case, again, you start from 8.5 and then to the left. So in that case, you have the 8. At the most 8. Or if we say X less than 8 means 8 is not included, then you subtract 0.5. So you start from 7.5 to the left. And if we said X equal 8, you have to have a stripe here. You just have one number. So in that case, you add 0.5 and you subtract 0.5. So we go strictly based on this scenario that you have. Like in these problems, we are saying that X is less than 152, okay? Less than 152 means 152 also is not there. So in that case, we need to subtract 0.5 from that because X is greater. When it's greater, then you have here. So when you do that, then you need to have, now the number is not a discrete anymore. The number is decimal. So we could, since it's a decimal, then be allowed to use it. But now we also need to know the requirement. The requirement is that n times p and n times q, both are greater than 5, or they are very large numbers. Then we have to find mean and standard deviation. Mean is n times p, and standard deviation is NPQ. So that would give you this number. Now, rather than calculate X greater than equal to 52, we do 155.5. X greater than 155.5. You put it in the decimal. Then we have to change it to the, convert the X to the Z. And when you find it to the Z is 0.62. You could go from the table A2 and calculate, but the easy way is to use again the calculator, and both end. One end is 1.5. The other end, a very large number, arbitrary number somewhere here, which we pick 1,000. So calculator for normal CDF needs both endpoint, X1 and X2. Again, X1 is 155.5 because we want 152 to be included. And on the other side, you just use a large number, arbitrary number like 1,000. And mean and standard deviation we already calculated. So that gives us the value of probability. It means for us to do this discrete problems and find the probability of x greater than or equal to 152, instead of doing all these calculations, in order to calculate each of these and add together, we could change it to the decimal, and that would give us the probability. So that's conversion of the discrete to continuous problems. You see here, this is a binomial or discrete number, and if you want to change it to the continuous, you need to, this is a case that x is between 152.5 and you have to subtract, you have to add and subtract from 155. So that would give you the continuous or normal distribution curve. This is another example in survey of 1,470 people, 931 people voted in pre-election and 61% of success. So n, x, and p-value are given. Find the probability that among 1,470 randomly select voters, at least 931 actually voted. So that means you want to find probability of x greater than greater than or equal to 931. So first we have to see if the requirements are met before we change the discrete number, which is the whole number, you're talking about the people, to continuous. NP and NQ both are greater than 5. Then we calculate the mean and the standard deviations. Then we convert x to z, which, as I mentioned, when you use the calculator, you don't have to go through this part. But anyway, x greater than 931 means you have to subtract 0.5 from 931. Why? Because you want 931 to be included. So in that case, x greater than 930.5, if you do the z1, that's how to do it. Is you do the conversion to the z and then do the problems. This one, again, we want to calculate probability of fewer than 3. Fewer than 3 means 3 is not included. So it means probability of x less than 2.5, because you don't want 3 to be one of the number. We calculate NP, both are greater than 5. We convert to z. Then you could also do it through this formula. In that case, you don't have to do the conversion if you don't want to. In this problem, we want to find the value between exactly 235. Exactly 235 means you have to find the area in order to want to use the continuous. So we don't have probability of x equal to 235. Probability always has to be greater, less, or between two numbers. It has to be in form of inequality. It's because we need to have the area. So in that case, in this case, we are adding and subtracting 0.5 when it says exactly. So when you see the word exactly, like this example, what is the probability of x is equal to 8? So you have to have an area. In order to have an area, you have to add 0.5 and subtract 0.5. So in that case, you create an area. So it's like this problem. It's a probability of exactly 235. So we have to add and subtract 0.5. And then again, you do the conversion to the z and then do that, or you could just go ahead and put the numbers for x1 and x2 and do the problems. All right. Now for homework problems, If NP and NQ is greater than 5, estimate fewer than 6. X fewer than 6 means 6 is not included. So we subtract 0.5, so X is less than 5.5. So if you go to the normal CDF, your area is 0.5. Your X is 5.5. And 0. If you want to calculate that area, the lower point is 0, the higher point is 5.5. You calculate mean and standard deviation, that give you the area. Number 2, before you actually do the problem, you want to make sure that the requirement is met before we continue to do the conversion. If the requirement is not met, you cannot do the conversion. See, in these problems, when we do the calculation, the second one, NQ, is not greater than 5. So we cannot convert discrete to the continuous for problem number 2 because it doesn't meet the requirement. This problem number 3 said find the probability of at least 11, means X is 11 and above. So in that case, you subtract 0.5. Why? Because you want to have 11, 11 is included. So in that case, you need to find this area. So the left point is 10.5, and this point, since you don't know what it is, you just give it a very large number, arbitrary number, like 100. That gives you the area. X is less than 30. That means 30 is not included. So we subtract 0.5 from that. So we start from 2.29.5 and less. X is exactly 37. When it's exactly 37, you have to add 0.5 and subtract 0.5. So in that case, you are creating a stripe here. And then you could use the formula. These are both ends. NP and NQ both are greater than 5. And then you use your calculator or normal CDF, which you have X1, X2, mean, and standard deviation. Problem number 6 and 7. Again, they want the X to be exactly 491. So you add, when you said exactly, you add 0.5 and subtract 0.5. Or in part B, they want X to be at least 491, means they want 91 to be included. So we subtract 0.5. So in that case, 491 would be included. The rest are all multiples to number 7. X greater than equal 34 means 34 is one of the numbers, so you subtract 0.5. X is also included 1001 in problem number 8, so we are subtracting. You could also put the 1000, but and the rest are all multiple choice questions.